I want to thank the MCAA for inviting me to give this webinar. Um, I'm going to assume that many of you are familiar with uh, the masonry industry's initiative to develop building information modeling tools for masonry. This is a project in which I led part of the initiative and was the primary author on the industry roadmap, which has most recently been published. And I'm a professor at the Georgia Institute of Technology. I'm a structural engineer by trade, but have been teaching on architects and engineers and constructors building science for the last 20 years. So have a fair amount of background in masonry from a structural perspective and a construction perspective. So my point of view is one of someone who is highly involved in the technology, but also aware of the frustrations of trying to implement the technology. I'd also acknowledge the support and kind of oversight of my colleague Chuck Eastman here at the Georgia Tech Digital Building Lab. Chuck has been working in building information modeling and allied technologies for over 30 years. So he has overseen many of the projects that have brought the technology to where it is today. And I think as people who put buildings together, who make masonry buildings happen, we're familiar with architects' drawings and intentions about masonry, but recognize that there's a lot going on behind the scene. And I think the same is true with building information modeling. We can think of all of the sorts of drawings that we're used to getting and all the aspirations that people have about their masonry buildings, but none of those drawings and none of those aspirations fully represent what's going on behind the scene, what it actually takes to put a masonry building together. And so our project is really to listen to you and to understand what the frustrations are with putting masonry buildings together, with documenting them, with managing the flows of men and material on job sites, and to the degree possible, embedding information in software in a reusable way so that your job will be made easier, that you can remove uncertainty from your projects. You know when something's going to happen, you know where something is, you know where your people are, and you know what they're doing. And those sorts of questions can certainly be assisted in a BIM environment, but they're not done so today. So I'm going to take a minute and I'm going to go over a few definitions. I know that these definitions are technical, but I think unless you are comfortable with the definitions about what BIM is, then you're going to have certain misconceptions about what BIM is and what BIM isn't. And so the process of BIM modeling is really the process of linking all of the information that you use, whether it's technical information about your masonry units, about where they are on the job site, or whether they're still in manufacturing, whether they have some kind of lead time associated with them. The BIM process is really about linking a model together that contains all of this information that you need to construct a masonry building. And the building model is the actual data repository. And I think it's more than just Revit. In fact, Revit is a tool that is used primarily by architects and engineers to build the modern day equivalent of contract documents. And the BIM model that you use may contain Revit or may be partially built by Revit, but it's more than that, because a proper BIM model contains information about scheduling, about materials, and those at current time, that information is not embedded in Revit. So I think Revit is a great tool, and part of our support here at Georgia Tech comes from Autodesk. So we don't speak ill of them in any way, but I think it's important to recognize that BIM is an umbrella set of technologies that are more than just one piece of software. Another important thing is workflow. I mean, you all understand your workflows in your office, whether they be electronic or manual, and I think that what's important is that part of a BIM process is understanding your workflow. How do you do things in your office? How do you transfer information from the estimator to procurement to job site superintendents to people running individual masonry crews? All of that is a workflow. And unless we understand your current workflow as mason contractors, we don't have a lot of hope of improving that workflow through BIM. And so we don't want BIM to be just another obligation that you have to the general contractor. Rather, we want to make BIM part of your workflow and allow you to work faster and smarter. Because ultimately, unless you put a masonry unit in the wall, that might be the only value-added activity at the end of the day. Is everything that you do to get a masonry unit in the wall is kind of a value-added activity, and all the other stuff is not. And so part of a BIM process and part of what our project is about is understanding how to improve your information flows. And as a technical aspect, what we have to do is we at Georgia Tech especially are specialists in understanding schema and data structures. That is, what is the underlying representation of masonry in a BIM system? Because currently, software like Revit does not represent masonry. It represents a wall, and it can put an interesting looking pattern on the surface of that wall that makes it look like it's masonry, but it's not. If you query it, it doesn't tell you that it's bricks. It doesn't tell you whether it's a cut brick. It doesn't tell you who supplied the brick. And so part of our work is to develop a data structure for BIM. Sorry about that. My computer was very slow to advance. You'll hear a few additional terms that aren't as important. One is interoperability, and what this means is that the data that you use in your office, you shouldn't have to generate it over and over and over again. And probably the most common example we use is the fact that architects and engineers put buildings together, and you can't necessarily use the information that they generate to do quantity takeoffs and cost estimating, because the tools that you use in the office aren't commensurate with or don't communicate with the tools that you use for quantity takeoff and estimating. So interoperability is a big deal in BIM, and is something that we're working on in the Masonry BIM software. 3D modeling just means that we're going away from flatland plans and elevations, and we're going to be developing all of this information in a 3D environment so that we can view the building as it's being constructed. And our deliverable here at Georgia Tech, ultimately, to the BIM for Masonry initiative is a software specification. And what that is a set of desires and workflows so that software companies like Autodesk, Bentley, Tekla Structures, and others will be able to develop the Masonry BIM software that we hope to be using in a few years. I'll also talk about two allied technologies which depend on BIM. One is called a virtual mock-up, and I'll show you an example of that in a second. And the other is virtual design and construction. It's a term that is used to represent all of the 3D geometry in a building, as well as a fourth dimension, time, meaning that the model somehow is tied into the project schedule, and a fifth dimension, which is cost, which means that the building information model is tied into your cost estimate. And so here's just an example of a virtual mock-up, and what we mean by a virtual mock-up is that one small part of the masonry building, in this case, we like the idea that a small fragment of the building that shows an interior corner, an exterior corner, windows, doors, and the connections, the foundations, an elevated slab, and the parapet condition can all be shown together. And although what you're seeing now on the screen is not BIM, because this rendering was created specifically for this discussion, what we would imagine in the future is that when we have virtual design and construction implemented in BIM, you'll be able to select a section of your building and you'll be able to have a drawing like this, and you can imagine that on a Wednesday you can show this drawing to your crews in the morning, and say, by Friday we need to be here, and by Monday we need to be at the top of the wall. And so the idea is that BIM is a computational environment in which those sorts of things that you might wish to do to communicate with your masonry crews are going to be made possible. And so this is just a fancy rendering at this time, but we're developing the underlying data structure for BIM. And I think what I would like for you to do is, as mason contractors, even as we go through this discussion, is to write down the things that you need, the hardest things that you do in your office today or on the job site involving masonry, and how you think this technology might help. And that's an important input to our process. And guess what? We're behind. You've probably heard this. The American Institute of Steel Construction started developing its material system in BIM about 20 years ago. And so if you're used to looking at structural steel shop drawings, you'll know that almost all of them are developed now in BIM platforms. And this has had a dramatic impact on the structural steel industry. They develop much more complex details and are able to get shop drawings out much quicker than they used to be, and make changes in shop drawings much more efficiently than using past methods of manually producing shop drawings. So we're a little bit behind. Note it here at Georgia Tech, my colleague Chuck Eastman has developed a BIM standard and specification for precast concrete. The precast concrete industry has funded the Tekla structure software company to produce a BIM application for precast, which is now widely used in the development of precast buildings, and it contains all of the double T's and spandrels and other common precast elements within the software, and allows for rapid generation of building propositions in precast concrete. Likewise, the American Concrete Institute now has a BIM committee that meets twice a year and is developing standards for cast-in-place concrete construction augmented using BIM. So it's good that we're in the game as masonry, but it's not good that we're behind. So part of the project that I'm talking about is our strategy to catch up and maybe even leapfrog these other material systems. So part of understanding what masonry BIM needs to do is understanding our stakeholders. That means all of you out there who have some interest in masonry or in BIM, some stake in the game. And this spans from, at the top, building owners, all the way down to the masons themselves who ultimately put the buildings together. So if we look at what our project has done in the first phase, is we've gone out and surveyed all of the stakeholder groups that we've identified, and kind of tried to understand what their hopes and aspirations are, what their problems are. And you can see here, we're in the general contractor, mason contractor community here today, I imagine. And so what are the tasks? We've identified, at least for now, these 7 tasks where at the contracting end, we want to see BIM tools for masonry. So we want to coordinate, we want to promote safety, We want to develop long-term business with clients. This is a very important task for general contractors, or aspiration with general contractors. They want to be seen as high tech. They want to be seen as delivering a high-end building on time, on budget, and to the extent that we as mason contractors can help the general contractors, that's going to mean that we have more work. On the kind of day-to-day scale, we want planning tools for masonry, we want to increase productivity, and we want an effective tool for communicating with masons. So all of these are within the stakeholder community in terms of needs. I'll talk a little bit more about this in a few minutes. You know, I'm going to talk about some of the other stakeholder groups and what they've asked for, because we're all part of a broader community. You know, one of the aspects of masonry construction is that there is an incredible library of masonry types from many, many different industry segments, and there's no common repository, digital repository of masonry units. So if I'm doing structural steel construction, it doesn't matter who rolls the steel. The steel is standardized, and I know that I can get that information on that steel from a common database. But there is no common database for masonry units. And so one of our activities in the BIM for Masonry initiative is going to be to develop a format and structure for a common database for masonry units, whether those units come from the cast stone industry or the clay masonry industry or the concrete masonry industry. And ultimately, we expect that that same database can be used for custom masonry units, whether it's a cast stone job or a cut stone job. So that's one aspect of BIM that's, at least at the early stages, primarily involving the masonry suppliers. We all work with architects. My day job is training architects about how buildings go together and how masonry buildings are put together. And you know, one of the huge advantages of masonry as a material system is its flexibility in design. And so if you're not familiar with these four buildings, there's one kind of famous historical example in the upper left. This is Frank Lloyd Wright's Johnson Wax building. 200 different brick types were created to create this building. The complexity of managing where all those are, where they are in the production chain, where they belong on the building, is a task that would certainly have been enabled by BIM. On the right, the upper right, you see the Tongshin Gatehouse from Office Da Architects. This building was designed in the United States and was built just outside of Beijing in China. In the lower left, this is the Yale University Health Services building. It's brick masonry construction, and the walls are tilted out at 7 degrees from plumb. Probably some of us do this by accident every once in a while, but this is done on purpose. And finally, on the right, you see the facade of the Southern Polytechnic State University Design 2 building. This is a brick facade where the brick is actually reticulated or rotates as you pass along the facade. Designed by Cooper Carey Architects and constructed by Jolly Masonry here in Atlanta. So beautiful examples of masonry buildings, and all of these buildings were, or at least the 3 out of the 4, were modeled in CAD systems and some even in BIM systems. Of course, the Frank Lloyd Wright building was not. And so we know about architects' processes with BIM. Architects were the first to embrace BIM because the architecture environment is all about building modeling. But when you take the kind of building form modeling and you overlay on top of that a BIM system, and what you see here in the BIM system, this is a prototype we developed about 5 years ago for the National Concrete Masonry Association. What you see is that the BIM system understands a concrete block wall in running bond. The earlier model was just kind of a form model used by the architects. So the kind of challenge we have is, how do you integrate kind of detailed construction information about wall systems with what architects do in their normal process. Structural engineers have a different kind of need within BIM, and they are also, I'd say, well integrated with the process. What you see here is in the upper left-hand corner comes from Bentley RAM, and our industry funded an initiative led by David Biggs, who's our industry lead on this project as well, to develop better computational tools for structural engineers so that they could more easily analyze and design load-bearing masonry structures. And as an aside, I teach in this area here at Georgia Tech, and can say that over the last 20 years, the structural engineering knowledge of how to design load-bearing masonry structures is waning, sadly. And these initiatives to bring these tools back into the software in an integrated environment are very important. Structural engineers are also involved in wall detailing, and due to changes in seismic codes and perhaps a lack of knowledge about masonry construction, load-bearing walls are ubiquitously reinforced these days. It's become much more difficult to do unreinforced load-bearing masonry, and all of this reinforcing adds significant construction challenges, delays, complexity to masonry jobs. And so we're producing a lot more shop drawings, even on concrete masonry, than we were at one time. And many contractors have to farm this out. They don't necessarily have in-house talent to draw shop drawings. And the shop drawings are kind of a deliverable to the general contractor, but they're never really used, or they're not significantly used during construction. And so part of our challenge in developing BIM tools is to be certain that we provide you, the masonry contractors, the ability to generate your own shop drawings, as well as to make them useful for you in the field as tools with which to communicate with your masonry crews. And so as part of our phase one process with masonry contractors, we developed a survey to ask masonry contractors what was most important to them about new digital tools and construction information technology. So you can see the ratings here from your colleagues, and this is a fairly small sample. I'll talk about this later, but if you say, what were the top things that mason contractors identified as areas where they need help? Preliminary or alternate estimates. 90% of those responding identified this. Way for the contractor to communicate with the architect. 100% detailed material takeoffs and cost estimating. Right? Why do I have all of these architectural and engineering drawings, and I can see that all the masonry is in those drawings, but I can't use that at all in my estimating? Shop drawing production, 90%. Production planning, including crew sequencing and scheduling. 100% of those surveyed identified this as a key component of masonry BIM. So here, well, I apologize, I'm having a difficult time advancing my presentation. I'm not sure. Oh, there it goes. Thank you. So again, this is just a continued slide from the previous page. The lower numbers represent areas where contractors were not as interested in including these technologies in BIM. Only 50% identified shoring, 70% material delivery. Complex detailing at masonry interfaces. 100% of those surveyed said that this was an issue where BIM could help. And this is really the role of our virtual mock-up, right? We're going to develop incredibly intense details of masonry buildings at the interfaces between floors and walls, walls and roofs, walls and other structural systems such as precast, cast in place, and structural steel. And finally, coordination with MEP. So what I would like to say here is that This survey was preliminary. We reached a rather small audience of contractors who came to Georgia Tech last year and helped us understand the mason contractor perspective as we developed this idea of building information modeling for masonry. And as we move ahead this year, I want to talk about a project in a few minutes where we're going to need more of you to participate, a larger segment of the mason contractors industry. So let me just talk again about more of your tasks and how BIM might help. Many of you recognize this snapshot from Tradesman Software. I would suggest, I guess from talking to Bill Pacetti, that he has between 50 and 75% of the market share of major mason contractors. And they have incredible interest in our project because they want to tie their software to the earlier models created by architects and structural engineers. And the way to do that is through BIM. And so what I would just highlight here is here's a little code. You're starting to think about what I would call data schema. I'll just look at this little code and say, well, here's a code that says U3225SB. And this is a certain brick coursing that's in this building that they've generated, a fairly complex building. And it's done a great job of counting all the pieces. The Tradesman software does that. But this is only because the mason contractor completely remodeled this building within Tradesman. So what you can see underlying this is the traditional architect's drawing, which would now probably be provided in BIM. So the question becomes, why do you have to spend the time and money and effort to completely remodel this building in Tradesman and to map these kinds of funny codes, U325SB, onto the building, when in fact the architect could be essentially building this model for you as part of his design process? That's the whole promise of Masonry BIM. You know, we're all familiar with the construction process of masonry buildings and how it is somewhat incremental through a process, and how masonry crews are always getting moved around on job sites. So this is just an example I generated to discuss some of the masonry tools that we're envisioning for Masonry BIM. In this case, you know, a project scheduling tool. You know, how much longer is it going to take to complete this fraction of the wall? What's missing? What masonry units are missing? How many crews? What's the scaffolding needed on that side of the job site? Is that scaffolding already on the job site, or is it back? Is it back on the back in your boneyard at your home office, or have you got to rent it? If you've got to rent it, how soon can it be delivered? So many of you are probably familiar with RFID tracking, and so it is. We have a colleague here at Georgia Tech who I'm working with to establish RFID tracking for things like the scaffolding itself and masonry units as they're delivered to the job site. So you can imagine in a modern-day BIM system that when masonry gets delivered to the job site, you'll be able to understand when it was delivered, where it was delivered, how much of it was delivered, and so there'll be an electronic transfer of information from the masonry supplier to you when that material is delivered. Again, as an aside, I'm working on a project with starting it with some colleagues here at Georgia Tech, looking at alternate modes of masonry delivery so that masonry can perhaps be delivered right onto the scaffold instead of having to be put on the ground, broken up into smaller units, and then transferred up to the scaffold. Another potential for Masonry BIM is identifying all the long lead time and specials on a job site. So in this case, if you have cast stone lintels on a job site, it would be good to know how many of them, how many different types, where they are, and when you expect them to be delivered. In addition, in this example, we have these cast stone lintels over the high bay doors, which are probably way too heavy to be lifted into place from the scaffold. And so you've got some construction planning to do based on the arrival of these lintels to the site that you need to accommodate within your process. The scaffolding might be in the way of the lull or whatever you're going to use to lift them. And so part of our process is to help you with masonry planning tools that can help facilitate these sorts of operations. Finally, if you think about wall bracing and safety zones, we know that after certain masonry construction operations, parts of the job sites have to be blocked off or roped off for a period of time while the wall's curing, and you've got to install bracing during those times. And so it would be good to be able to communicate with your general contractor and the other trades on a day-by-day basis what you're planning to do, and also to use these tools as a what-if, as a gaming tool, so that if you've got to change the order of construction because of unintended material delays or other conditions on the job site, you can accommodate that. Finally, shop drawing production, we've kind of talked about that, but that's another tool we imagine embedding in Masonry BIM. Let me talk a little bit more about virtual mock-ups, and some of these examples come from colleagues at Mortensen Construction. I'd like to acknowledge them for sharing these. And they do a lot of what I would call custom drawings for their masonry buildings. They don't have masonry BIM per se. What they have done is that they have developed and hired a staff of essentially architects who can create very convincing and detailed drawings, redrawing parts of structures fully in 3 dimensions to facilitate the construction process. And they refer to this as virtual mock-up and also virtual design and construction. And we all know that architects' drawings, like that shown on the left, are sometimes really hard to interpret what's going on. The traditional section contains a lot of information, but it doesn't tell you how to build, and it doesn't tell you when to build. And so in Mortensen's process, they're drawing parts of buildings in complex areas where things are coming together in unique or difficult ways to try and figure out flashing, vapor barriers, water barriers, the dry line, parapets, etc. And so this drawing on the right doesn't really represent BIM in that it's a custom drawing produced for this condition by a very talented draftsperson. If we had a convincing BIM database for this building, a convincing masonry BIM model, then I could, as the masonry contractor, simply select that area of the building and say, show me that area of the building in virtual mock-up mode. And so we're a long way off from that. I don't want to mislead you, but that's the kind of functionality we aspire to. And so in this case, what Mortensen did is they had someone draw this, and from my own perspective, being a SketchUp user myself, I would imagine that this is a 4 or 5 hour drawing right here. So you know what you pay your CAD draftsman an hour. So that's what they invested in drawing this, but clearly they felt like it was worth it in terms of communicating to the various trades on the job site. Again, the advantages of models like this is that we can actually show time-lapse construction, and so we can show our people on the job site exactly what needs to be done on a given day and in what order, and that's really important. Finally, I think you can imagine tools in the future where we can extract information from BIM and beam it right to our people on the job site. Those of you who know David Biggs, you may have heard him give a presentation on this technology. It's coming. You can imagine being able to put masonry information right on small devices like iPhones. That is to say, imagine we had an application on the job site called Masonry Finder, and everything on your job site was RFID tagged, not to the part level, but at least to the bin level. And so anything that was missing could be identified using an app on an iPhone or other portable device. So this is really the function and the reason for our BIM roadmap. Right? We want to get to a place where architects, contractors, engineers, masons, our whole community, masonry suppliers, can benefit from a more integrated industry. And what is great about the BIM for Masonry initiative is there's nobody who doesn't want to play. Everyone's interested in the technology. Everyone sees a benefit in participating. And so many of the kind of parochial challenges that often happen in the masonry industry, let's say the clay masonry suppliers versus the concrete masonry suppliers, that's kind of erased in this initiative because we recognize that everyone is going to benefit from a more streamlined design and procurement and production process in masonry construction. So we've got all of you today participating, and I greatly appreciate Jeff Buckowitz and Tim at MCAA and their support of this this project. We've worked closely with Ed Davenport, who's been a leader of your organization. He's given us many challenges to think about in our project, but we also have the concrete masonry suppliers, the clay masonry suppliers, the Brickworkers Union, and the Masonry Society as part of the team. So we really are fortunate to have everyone's perspective and support, and so we're positive that we're going to make some great strides for the industry as a whole. Just briefly, the leadership of this initiative on which I'm working. Jeff Buckowitz of MCAA is on the advisory board, along with some of your members. Jim Boland from the union, Dave Savinsky from IMI, Tyler Withune from the National Concrete Masonry Association. Tyler is actually going to be taking a leave of absence from NCMA and is going to be joining me here at Georgia Tech for the next year and a half to work on this initiative. Jeff Elder from Western States Clay, Art Thusch, Daryl McMillan, and Dan Zeckmeister. And in addition to what I would call the major players in the masonry industry, we also have a huge group of affiliated members who are giving, if not their talent, then certainly their time to the initiative. So we're very lucky to have just about everybody on board. And so we've developed this roadmap. It's available on the web. You're welcome to download it and read it. God bless you if you read all 150 pages. But I think what's important is that we've identified a 5-year path towards masonry BIM. It doesn't mean that you have to wait 5 years to see any benefit from this project, but you do have to recognize that there's a lot of moving parts, a lot of stakeholders, and a lot of things that we need to do. If you look at the roadmap graphic, you'll see that we're here in this early stage of planning for phase 2. The first contracts for work are going to be let here in the next month or so, and so we have 4 projects kicking off in, let's say, the next 1 to 6 months. And I'm going to briefly describe these, but I'll highlight before we move ahead that one of the major projects is what we call this bim-m contractor input, and I'm going to talk more about that project in a minute because it involves you specifically. And we need your help on this. This is not something that we're doing for you. This is something we're doing with you. The Masonry Unit Model Definition is a project primarily for the suppliers of unit masonry. This is a data structures project so that we can develop essentially online databases of masonry materials, their geometry, their material properties, their suitability for use in various climates, etc., etc. These same sorts of databases will link into their internal MRP systems of masonry providers so that when you say, I need such and such of a bullnose brick in such and such a color, they can immediately query their system and find out if it's in inventory or if it's in production or if it needs to be a custom unit. This Masonry BIM benchmark, this second project in phase 2, is really going to challenge all of the current software providers, Autodesk, Bentley, Digital Project, ArchiCAD, all of the BIM system providers, there are more, to show us what they got. In other words, they're going to develop their best masonry BIM models during this project and show us what their current state of the technology is. And then we'll be able to find out what the best practices are with the current software, as well as what needs to be done to make the software more masonry aware. And finally, we know that masonry units themselves don't make masonry buildings. Masonry buildings are constructed of masonry walls. There are many, many types of masonry walls, and masonry walls are a marriage of many, many different materials. And so a more complex project is actually how do you define a masonry wall in BIM. But let's go quickly and now talk about this contractor task as we wrap up. Because again, what I'm trying to do today is to encourage you to become part of that project. I think I've said enough about the four projects in my previous slide. So let me go right to the Mason Contractor Project. And I'm going to go into detail about what we're going to be doing. We're going to revise and resubmit the survey that I showed you earlier to a wider range of mason contractors. And so I'm asking Jeff to encourage you, all of you who are on the line of the webinar today, as well as your colleagues, to provide your input. What are your aspirations for Masonry BIM? The second task is to identify best practices of BIM in non-masonry subcontractor areas. There are other subcontractors, ones that come to mind are perhaps mechanical contractors, curtain wall contractors, certainly structural steel subcontractors who are using BIM already, not as a kind of side part of the project because it's a contract requirement, but they're essentially using BIM to do their work, and it's making them better, faster, stronger, and that's what we want. So we will be kind of piggybacking our ideas for masonry BIM on top of what other subcontractors are doing. This third task, again, I'm doing this right now. I'm soliciting input from you, but we also need to solicit input from general contractors and construction managers. It's important for you, and Ed Davenport has done this with me more than once, it's important for you to tell us what you're hearing from general contractors and construction managers, right? What are the problems, what perceived problems do they have with masonry construction, and how can we use BIM to address those problems? So that's an important consideration, because clearly at the end of the day, we want this project to generate more masonry buildings. So I think whoever is involved in running this project, this specific project within our initiative, we're going to be meeting with you at your annual meetings. We hope to hold focus groups so that you can tell us what you need us to do in detail, not just in general your aspirations, but actually how you expect to interact with Masonry BIM, how you're going to train your people to use it, and what you might expect to pay for it. This part number 5, I think that what we would like for you to consider is hiring our students, not just at Georgia Tech, but others who are working on this project as interns with your contracting firms. I recognize that times are tight in the construction industry, but part of what we have to do as a software provider and a middleman, and that's what I am in this project as a middleman, is I have to understand your needs. And by embedding my students in your process on a day-to-day basis, I can better understand your needs. And then when we have a sense of how the software is going to work, we can then use our students and say, well, if we provide you with this tool, this tool in the field for finding masonry units, or this tool for locating your scaffolding, or this tool for seeing if the lintel's in the right place, would they use it or would they not use it? Would they think it was silly? So that's why we need to know more about your process. And we're going to prepare scenarios of use. What we mean by that is we're going to storyboard the BIM software, and you could see that already in the graphics that I've shown you today. We're going to prepare scenarios of how the BIM software is going to look and how it's going to work, and then we're going to ask for your feedback as to whether that would be something that you would use in your practice and how you might have to change your work process and workflows to use the tools. And so finally, at the end, Art Tush, who is our collaborator on this project, who's been an immense help on the BIM contractor side, is going to develop a series of educational programs and seminars and webinars like the one today, to introduce you to the BIM tools that we're developing for masonry. So we're kind of wrapping up here now. I appreciate all of you listening in, and I'll just make a final plea that this is not something that we at Georgia Tech or even the overall BIM for Masonry initiative is doing for you. It's something that we're doing with you. And without your expertise, without your input, the BIM tools that we developed will be certainly of use to architects and engineers, but we feel that perhaps these tools will have the most impact on the contractor side, because frankly, architects and engineers are already using BIM, and they're using BIM with all those other material systems. So we want to provide the tools for masonry to get them excited about masonry BIM, but also to make your work easier, faster, and smarter.